I'm going to be up front today and say that today will be an easy day, but since I'm the math teacher, you can't really take my word for it. But I think it will be, even for those of you all that don't like this subject. So I'm going to go over into solving some equations, stuff that involves some factoring, also isolating variables, and I think it's going to be maybe one type of trigonometry question. But all of these are ACT questions, and I just want to kind of go into some techniques on to how you can get a correct answer or maybe do some elimination. So here's the question. It asks, what is the slope-intercept form of negative 3x minus y plus 7 is equal to 0? And then you have like 5 selections here, all right? The first thing that they give you here that you pay attention to is, number one, you got to know what slope-intercept form is, right? They tell you slope-intercept form, so they kind of expect you to know what slope-intercept form is. If you don't know what slope-intercept form is, it is that. Y is equal to mx plus b. That's slope-intercept form. But there's some good news. Even if you did not know that y is equal to mx plus b is your slope-intercept form, every last one of your answers are already in slope-intercept form, because that's what it wants us to choose anyway. So right here, all of these are already in slope-intercept form. So even if you didn't know the form, like memorize it or anything, that doesn't matter, really. That brings me to what we really should be thinking about. This is when we say isolate the variable. This case, we're going to be isolating the y variable. We also call that solving for a variable, or solving for y. If you see a variable by itself and is equal to a whole statement, that means that variable is the one that has been isolated. That's the one that's by itself. If you look at this as a street, right? All of these people on one side of the street, and this y variable is by itself. This person has been singled out by itself, isolated. That's what we mean by isolating a variable. All right, so this problem can be done in one step. We're going to make one move because that's the one that needs to be isolated. I'm going to circle this one. And then I'm going to draw an arrow to where I want it to go. So I want it to go over there. And remember, anytime you isolate the variable, the sign gets circled with it, all right? You don't ignore the minus sign. That's where most mistakes happen. So that is a negative y. But remember, anytime we cross over this equal sign, that negative y will disappear, and then it'll pop up over here as a positive y. It's almost like magic. All right, so now that it popped up over here, we know that 0 plus y is just a regular y. So technically, this is going to say y is equal to. And you see what else is left. Now it's a negative 3x, and it's a plus 7, which means y is equal to negative 3x plus 7. That's your answer. Y is equal to negative 3x plus 7. And there it is right there. And you know, math is probably one of the only subjects where you can read from left to right if need be. So y is equal to negative 3x plus 7. It's still saying the same thing. This is just saying negative 3x plus 7 is equal to y. It means the same thing. You can read it left and right. All right, so this problem says, which of the following is a solution to the equation? So we have x squared minus 16x is equal to 0. And once again, you have 5 choices. Before I get into working this problem out, or how do we get to a correct solution, we got to know what a solution means. A solution is a true statement. That's all it is. If you say, or you pick a number that gives you something that is false, that is not a solution. I'm going to go through 2 ways of getting the correct answer. One is going to take a little bit longer. And remember, anytime you take an ACT, you have 60 minutes to do 60 questions. That's like 1 minute per problem. So this definitely goes against that, but it does give you a correct answer. This way works for people that don't know how to do things the right way. So instead, we go check solutions. All right, when we check solutions, the number one thing you want to do is write down the original problem. And then everywhere you see a variable, you want to write down the problem with parentheses as placeholders. Variables are nothing more than placeholders in the first place. So what we're doing is we're just making room for a number to go in there. And the numbers that we pick will be coming from this list. So I'm going to start with the first one up here, which is 32. And I'm going to put my 32 in here. So if I put my 32 there and I put my 32 here, 32 times itself is 1024. And then if you do the 16, if you multiply these two, you'll get a 512. We know that that's not equal to 0. So 32 is not one of the solutions, all right? Now, if you're going this route, you cannot mess up on your arithmetic. You have to be able to multiply, add, subtract properly at all times if you're going to check your solution. So now try 16. 16 times itself is 256. All right, 256. Then look what I have here. I have a 16 times itself. Now I have a minus 256. And I think we all know that 256 minus 256 is 0. That is the solution. All right, so this problem here, I'm going through an algebra technique. All right, so this one is going to require some factoring. And the reason why I know that is because this has an x to the second and that has an x. So I know that they have a single x variable in common. All right, so x is what they have in common. So that means if I do x times x, I'll get an x to the second power. That's why I put an x there, because x times x is x to the second power. Now, if I do x times a negative 16, I'll get a negative 16x. So that's why in parentheses I write negative 16. So now I'm looking at x times x, that's x to the second power. I'm looking at x times a negative 16, and now I have a negative 16x. That's how we factor. So we call this factoring because we broke these up into two factors. X times these parentheses, those are your two factors. And since this is equal to 0, what that means is you take all of your factors separately, the ones that have those variables in it, and set those equal to 0. So I can set x equal to 0, but that's not one of my selections. So I know even though it is a solution, it's not the one that's listed. So if I look at x minus 16 is equal to 0, then it only makes sense. The only way that this whole box turns into a 0 is if I put a 16 right there. So x needs to be 16 for this to be true. And once again, x is 16 because that is what makes it true. Now, if you master your algebra, then of course you're going to use your algebra and factor. But remember, we're talking about average people across the board. A lot of people do not like this subject. A lot of people struggle with math. So if factoring isn't going to be your method to getting you to correct solution, then you got to know how to use your order operations. That's keeping all of your skills at the most basic and fundamental of the levels and using that to your advantage to still find your solution. All right, the other way you can do this is literally by using your calculator. If you have a graphing calculator, or if you don't have a graphing calculator, I suggest that you invest in one. They are awesome. They can do a lot of stuff. So I plugged in the problem right here, x squared minus 16x. It graphs it. Now remember, it was looking for the solution. So the solution on this screen is anytime we hit this line that goes directly across. We call that the x-axis. Anytime you touch the x-axis, that's what we mean by finding solutions. So this is designed to find those straight from the screen. And look, the first one is x is equal to 0. There's another one over there. I move the arrow, and then that one is x is equal to 16. There's the same solution that we got on paper. That's the same one we got when we checked solutions and factored. So it's different ways we can get to this same answer. Try to have the best tools available to you that will save you time. All right, here's the last example I'm going to go over today. This one reads, the velocity in meters per second of an object is given by the equation v is equal to 5/3t plus 0.05. T is the amount of time elapsed in seconds. After how many seconds will the object be traveling at 0.575 meters per second? the sheer length of that question is enough for most students that don't like this subject to look at it and say, I don't know. They see some words being thrown around like velocity. They start seeing meters per second. They see some fractions. They see V's and T's. They see all sorts of stuff. They see 4 lines that you have to read through, and then there's a question right there at the end of it, and it's just like, I don't know. By the time they get to the question, they already defeated. So I'm going to try to show you how you're supposed to dissect a problem like this, because this problem is pretty much as easy as the first one. So remember what I said, this is a long question. You got to know what the question is saying right here at the end. So that's the first thing you jump to. How many seconds? So that's the goal there. You read through all this stuff. The answer that you're picking here has something to do with how many seconds this is going to take. All right, so that's the first part. Second thing we do is we take a look at this equation itself. And it tells you up top, velocity is in meters per second. That means whatever number goes here has to be meters per second. Whatever number goes there has to be something that says meters per second. This one right here is T. Whatever number goes there has to be in seconds. All right. So that's just letting you know the placement of those values. So if I give you 10 seconds, you are not supposed to go over here and put 10 seconds there, because meters per second goes there. Seconds go here. All right. So that's the main thing that you want to pay attention to. If you understand that concept, then we can move forward to how you solve it. This right here, that's given information. And because that says meters per second, they just gave you the number for V. So the number that you're looking for is seconds. You're looking for T, but you were given V. So 0.575 has to go there. All right, before I get to working this out on the board, I'm going to show you how this works on the calculator. So notice what I put here. I put 5 over 3x plus 0.05, right? Because this calculator doesn't use V's and T's, the T variable that I was using, T, I'm just going to continue to use the variable X for it. So basically, I put in my velocity at the top, and then the number that they gave me, I put that one in on the next line on Y2. So there's my V is equal to the formula, right? V is equal to the formula. Remember, they gave me V. So when I graph it, it gives me 2 lines. Remember, I put in 2 lines. It gave me 2 lines. All I'm looking for is where they meet. And look where they meet. They meet at 0.315, which is right here. Remember, if you have one of these types of calculators, or you don't have one of these types of calculators, you probably want to invest in one and then learn how to use it, because I just turned this into like a 5-second problem just by reading it, plugging it in, the calculator itself finding my intersection. So we're about to solve this by hand. We already know what the answer is. I showed us how to get it on the calculator. So for those of us that don't have that calculator, we have to use what we know with algebra. So I can subtract that number on both sides of the equal sign. So I could put a minus here, 0.05. And then over here, there's my 0.05 over there. See that? Okay, now that I've subtracted, now I made that subtraction, this is what I have left. Now I can multiply both sides by 3. The reason why I multiply the right side by 3 and the left side by 3 is so that happens. That's the only reason why. All right, so now I have a 5t is sitting here now. And when I multiply those two numbers together, I get a 1.575. See that? I get a 1.575. Now I divide both sides by 5. And the reason why I divide the right side by 5 and then the left side by 5 is so that happens. Because remember, what we're trying to get to is the variable. The variable is now isolated, and now it's equal to whatever happens after I calculate here. And what I end up getting is the 0.315. So that's how we get that solution. That's how it happens right there. So those are two ways that you can get to that solution. I think the number one thing starts with understanding how to read that problem and knowing where to place those numbers. Because if you didn't know where to place a number, it doesn't matter if you have a calculator in front of you or not. You will always be lost. So you have to have a certain level of understanding just to get you over the hump. And from there, you're either doing things by hand or you're doing things with a calculator. But you have to get over that hump, and you have to have a certain level of comprehension first. All right, I think I'm going to have to stop right there. I'm not going to have enough time to go into that last example that I wanted to go into. So I'll probably do that when I come to work on Monday. So I hope you're following my channel. You can check the link in my bio. Subscribe to my YouTube channel. I'm putting these videos up every single day. You can leave comments, ask questions, all sorts of stuff. I try to engage as much as possible and try to come up with better videos to explain.